Let's try to look at another example of simple harmonic motion. And so over here, I have it's a crude drawing, and basically I have some type of a mass on a frictionless surface attached to a spring, and it behaves in a simple harmonic motion. And that motion is described by its displacement or its distance equals 10 cosine pi 6 over t. So I want to know a couple of things in this particular example. I want to know its displacement, or its d. I want to know its period, which is the time it takes for it to make one complete cycle. And I want to know what its frequency is. And frequency is identified by the amount it moves per unit time. So I'll give you another little equation to think about. Its frequency is its omega over 2 pi. And you're going, wait a minute, that looks real familiar, because its period over here was 2 pi over omega. And so period and frequency are inverses of each other. And so that will be helpful for us to think about. So in order to find what this is, I want to find out what its maximum displacement is. And I can simply observe that by looking at its equation, because I know that right here it's its amplitude. And at this particular time, at time equals 0, the maximum it could be would be 10. So I can say my maximum displacement will be 10, and whatever the unit is, this might be in centimeters or whatever it might be. So whatever its units are is what that would be. All right, then let's look at its frequency. Frequency equals its omega over 2 pi. In this particular case, pi 6 is its omega over 2 pi. I can reduce that down by, that becomes pi 6 times 1 over 2 pi. Multiplying that out, the pi's cancel, and I'm left with 1/12. So its frequency is that per unit time per second, this mass travels 1/12 of the distance of the cycle. And then its period, which is its reciprocal of the frequency, I could either take its reciprocal here, which would become 12, or if you want to just do the hard work because it's kind of fun, let's go back and look at period. Period equals 2 pi over its omega. Let's work that out. 2 pi divided by pi 6. That equals 2 pi times 6 over pi. Whoops, sorry, 6 over pi, folks. Pi's cancel, and I do indeed get 12 for the period that I have on this particular problem. So again, that's just an idea of how we can start to explore some different application problems, in this case, some simple harmonic motions that we observe either in frictionless springs, guitar string strumming, or anything else that you can kind of get a sense where we have some type of a little bit of a simple harmonic motion. So hope this chapter's been fun. I hope you learned a little bit. It does require, again, guys, it does require some effort and work, but I know that if you do it, it is going to pay off, and you guys are able to, and you will be able to grasp this information. So can't wait to see you in the next section.